Hello guys, this is Paulo Haddad and in this video I'll be talking about the commands VoltageBases, calcVoltageBases, setkVbase, and solve. These commands will be described in the same circuit used in the Y system video. The system has a circuit element called Thevenin equivalent, a three-phase transformer called T1, a B-phase line called Ln, a center-tapped transformer called T2, a three-phase load called L1, and finally, the single-phase loads L2 and L3. Let's solve this circuit by using Ctrl A and then Ctrl D, and check out the voltage and line neutral nodes report available on the Show menu. Looking at this report, we can see that it shows the voltage values in kilovolts. However, it's not showing the voltage results in per unit. We just see zero values for per unit column and base kV column as well. By going to the Show menu and then selecting the buses report, it shows us that the buses base kV property have not been specified. That's the reason why the voltage report is not presenting the voltage in per unit. This property can be included in two different ways. The first one is by using the command setkVbase. In this case, one should start the command line with setkVbase followed by the parameter bus with the name of the selected bus and the parameter kvll equal to the line-to-line voltage base desired. As our circuit element has a line-to-line voltage equal to 115 kV, let's set the KVLL property for this bus equal to 115. By running this command line, we can verify that the column per unit in the voltage line neutral nodes report has been changed for the bus 100 with the per unit value that we just set. And what changed on the bus's report? Well, for the bus 100, the base kV property has been filled with 115 kV as we just set. Now, let's fill the other buses with the base kV property. The KVLL for bus 200 is equal to 4.16 kV and for the bus 300 as well. Now, pay attention that the bus 400 is not a three-phase bus. I mean, its rated line-to-line voltage is not equal to square root of 3 times the line-to-neutral voltage. So, in this case, let's fill the KVLN property with 0.11 kV. In other words, in this bus, we have 0.11 kV for line-to-ground voltage and 0.22 kV for line-to-line voltage. It means that a square root of 3 times 0.11 kV is equal to 0.191 kV. That is different from 0.22 kV. That makes sense, right? Running these lines and opening the buses report, we got all base kV properties filled for the buses. However, looking at the bus 400, its base kV is equal to 0.191. What does this number mean? This is the value of the equivalent line-to-line voltage of bus 400 if it was a three-phase bus. In other words, OpenDSS shows the line-to-line voltage bases in the bus's report and keeps a square root of 3 relation between the KVLN and KVLL properties. This fact has some important implications in the voltage line neutral report. First, we can see that the per unit results for line to neutral voltage are correct, but when you look at the per unit results of the line to line voltage, we note that the base voltage used is 0.191, which is not correct for the two-phase portion of our circuit. And we know that it should be 0.22 kV. That's why an actual voltage below 0.22 kV has a per unit value higher than 1.1. That being said, if we always want to have the per unit line to ground voltage correct, we need to define the correct KVLN property for the buses that we know that are not a three-phase bus, or we can define the KVLL equal to square root of 3 times the correct KVLN. In our case, we know that it is 0.191 kilovolts. We can run this line and see that nothing has been changed on the bus's report. Then, one should note that for a non-three-phase bus, like in our case, you can only adjust either the line-to-line voltage or the line-to-ground voltage base, because OpenDSS forces the relation between these two voltages as if the bus was in a three-phase system.
Well, the first way that we have just discussed seems to be a little bit complicated if you want to set the base KV for all buses in a large system. Yeah, and that's why we have the second option, which is much easier than the first one. But before I show you that, let me comment these lines. In the second option, we just need to include two line commands before the solve command. The first line is the setkVoltageBases command, in which we define all the line-to-line voltage that we have in our system in kilovolts. In this case, 115, 4.16, and 0.191. Pay attention that this last value is calculated as a square root of 3 times 0.11 kilovolts. Please bear in mind this definition. Finally, the second line is just the calcVoltageBases command, responsible for setting to each bus a voltage base defined in setkVoltageBases. Now, let's check the buses report out and see if the base KV properties of the buses are the same. As we can see, everything is the same as before. Now, if you consider that we might have a system with different but close voltage levels, OpenDSS may set the wrong base KV for the buses in these regions with close voltage levels. That's the drawback of the second option. In this case, we can set the buses with problems individually. For example, let's consider that our bus 300 has base KV property equal to 4.5 kilovolts. In this case, we can just set the base KV for this bus through the setkVbase command as KVLL equals 4.5. Let's run this line and see the bus's report. We have base KV property for the bus 300 equal to 4.5 kilovolts as expected. Well guys, in this tutorial video we saw two different ways to include the calcVbase property for all buses in order to get the voltage results in per unit. And that's it. Thanks for watching.